Welcome, Math Masters! A new scroll has arrived at the dojo gates. Today, you'll begin training to earn the multiplying and dividing by powers of 10 badge. Consider the multiplication sentence. 7 times 10 to the 6th power. What is the value of this number sentence? How does multiplying by a power of 10 affect the value and place of the digit 7? What pattern do you notice when a number is multiplied by a power of 10? Study well. The path to mastery begins now.
Welcome back, Math Masters. It's Jenna and Mia again. We've worked with powers of 10 before, and we've seen how 10 to the first power represents 10, 10 to the second power represents 100, and so on. But for today's challenge, we must investigate what happens to a number when you multiply or divide it by a power of 10. I have a feeling we'll need our knowledge of place value patterns and multiplication to conquer today's challenge. Have your guided notes ready? Training starts now. We will begin today by trying out this problem. What is 4 times 10 to the second power? We did something similar in our last lesson when we solved real-world problems, like finding out how many toys a factory makes. First, we find the value of the power of 10. What is 10 to the second power? That would be 100 because 10 times 10 is 100. Then we add 100 plus 100 plus 100 plus 100, which gives us a total of 400. Great! But that was a lot of hundreds to add up. Is there a shorter way to solve this problem? Absolutely! The initial problem was to take 4 times the power of 10. So we could just take 4 times 100, which is also 400. This works because multiplication is another way to represent repeated addition. Great work! Let's investigate this problem further. Pause here to analyze our work and answer the following questions. What place value did the digit 4 start in, and where is it now? How many places did the digit 4 move? What happened to the value of the 4? When we multiplied 4 times 10 to the second power, the 4 started in the ones place, and it's now in the hundreds place. How many places did the digit 4 move? It moved 2 places to the left. And what happened to the value of the digit 4? We went from 4 to 400, so it's now 100 times larger. So, multiplying by a power of 10 shifts the digits to the left and increases the value of the digit. What do you think will happen when we divide? We know multiplication and division are inverses, or opposites. So, will division by a power of 10 have the opposite effect of multiplication? Let's find out with 3,000 divided by 10 to the third power. First, what is the value of 10 to the third power? 10 times 10 times 10 is 1,000. Now, we'll divide 3,000 by 1,000. Pause here to find our answer. So, what is 3,000 divided by 1,000? It's 3. Interesting. Which direction did the digit shift this time? The digit shifted to the right. How many places did it shift? 3 places. The digit 3 started in the thousands place and shifted 3 times to end up in the ones place. Did the value increase or decrease? It decreased. We were right. When we divided by a power of 10, the effects were the opposite of what happened when we multiplied. What do you think would happen if we divided 3,000 by 10 to the fourth power instead of 10 to the third power? That would mean the digit shifts 4 places to the right, but we've run out of whole number places. So where does it go? It keeps moving into the decimal places. When we divide by a large power of 10, the digits don't disappear. They move into smaller and smaller place values. Great job multiplying and dividing by powers of 10. Now, let's explore what happens to a single digit when we multiply or divide it by different powers of 10. We'll use a target digit of 6. Pause here to solve each problem in the table. As you work, pay attention to how the digit changes and record any patterns you notice. Let's check our answers. 6 times 10 to the first power is 60. 6 times 10 to the second power is 600. 6 times 10 to the third power is 6,000. What did you notice? Just like before, the digits shifted to the left, and each time the power of 10 increased, so did the value of the number. What about the division? What happened to the place and value of our target digit? It's also the same as before. The digits are shifting to the right once for each power of 10 and decreasing in value. We get 6 tenths, 6 hundredths, and 6 thousandths. Oh, hey, Mia! You have a power-up technique to help us work with powers of 10? That's a great observation. There is a connection between the power of 10 and how many places the digit moves. When we multiplied or divided by 10 to the first power, the digit moved 1 place value. When we used 10 to the second power, the digit moved 2 places. And what about 10 to the third power? The digit moved 3 places. The exponent on the power of 10 tells us how many places the digit will move. Thank you, Mia! With all of this information, I think we're ready for today's challenge. Complete it, and the multiplying and dividing by powers of 10 badge is yours. Consider the multiplication sentence, 7 times 10 to the 6th power. What is the value of this number sentence? How does multiplying by a power of 10 affect the value and place of the digit 7? What pattern do you notice when a number is multiplied by a power of 10? Pause here to complete the challenge in your guided notes. Use everything you've learned today to show your mastery. When we multiply 7 times 10 to the 6th power, the digit moves 6 times, the same as the exponent of 6. And since we are multiplying, the digit will shift to the left. The value becomes 7 million. Multiplying or dividing by powers of 10 changes the digit's place and value. left for multiplying, right for dividing. The exponent informs us how many places the digit will move. This pattern holds true when multiplying or dividing by any power of 10. Multiply by 10 to the third. The digit shifts to the left 3 times, increasing the value of the digit. Divide by 10 to the fifth. The digit shifts to the right 5 places, decreasing the value of the digit. So, what have we learned today? When you multiply by a power of 10, the digit's value increases and shifts to the left. When you divide by a power of 10, the digit's value decreases and shifts to the right. And Mia helped us figure out that the exponent on the power of 10 tells us how many places the digit will move. Remember, powers of 10 help us move through place values using a single operation. Truly powerful. You've earned the multiplying and dividing by powers of 10 badge, but your training isn't over just yet. Be sure to complete the practice questions and extension activities that go with this lesson to practice. And remember, Math Masters, in math, as in training, progress comes with patience and practice. I'll see you next time.
Hey, hey.